Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at a library of array functions by adding the ability to do array comparisons. In this series of videos I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. Today we're going to be looking at the comparison of arrays. What we have on screen at the moment are two text files. We have a yesterday file and a today file. We're going to be using some new functions in our array functions library to compare these two files in arrays. We want to produce three outputs from this comparison. An array containing the records which have been added between the yesterday file and the today file, an array containing those records which have been amended, and a third array containing those records which existed in the yesterday file but have now been removed from the today file. So to perform these comparisons, we're going to first load both of these files into a one-dimensional array and then report on them. So I've created four string constants. One for the yesterday file as a text, one for the yesterday file as a CSV file, and one for the today file as a text file, and one for the today file as a CSV file. We're going to be using the text files to load into a one-dimensional array first of all, so we will create a local function to perform that. This first function will load the yesterday file and the today text files into two one-dimensional arrays. So here is our new function, which takes two parameters, the string for the yesterday file and the string for the today file. We will now dimension two arrays to contain the data contained within those files. And since we want to produce an output for those records added, those records amended, and those records removed, we will create three additional arrays, one to hold each of those types of change. Now that we have all our arrays set up, let's have a look at the files again. Both the yesterday and the today file are pipe delimited files. There is a header at the top of each file and a number of records within the file, and each record is a string which is delimited by the pipe character. This gives us 6 columns, and the column which contains the unique information is the account column. So we're going to create three local variables, one to keep track of the delimiter, in this case the pipe character, one to keep track of the unique field name, which is the account, and one to hold any errors that occur during our comparisons. So we're going to use one of these standard functions within our PB file handling routines library. This will load the text file into an array. So that's our yesterday file loaded into the yesterday data array, and assuming that loads successfully, we will then load the today file into its array, using exactly the same function. Having successfully loaded both arrays, now we can look to compare them. So we will populate the unique field name as account, since the account column contains a unique identifier for each record. The delimiter is the pipe character, and we will set the array variable to be an empty len string initially. We're now going to use the new array compare function within our array functions library. I'll cover the detail of how this particular function works later on in the video, but for the moment we're just going to call this and see what we get back. Now this function takes a number of parameters, most of which are arrays. We need to pass the compare function the yesterday and the today arrays, and we're passing it three empty arrays for the added data, the amended data, and the removed data, plus details of the delimiter, the unique file name it's going to use for the comparisons, and a variable it can populate should an error occur. If this function returns true, then the arrays have been successfully compared. So at that point, the three arrays, added data, amended data, and removed data, should contain details of those types of comparisons. So we can then dump each of these arrays out to disk just to see what we have. So to do that, we'll use another function in our PB file handling routines library, the array dump function. There are only two parameters for this, the first parameter being the file to which you wish to save, and the second parameter being the name of the array whose contents you want to save to that file. And we'll do exactly the same for the amended and for the removed. If you do a lot of computation using string arrays, this comparison function should be useful to determine the difference between any two arrays who are in the same format. So should something go wrong and we have an error coming up, we can always report on that error to our log. So having set this function up, we're now ready to run the application. This will load both the yesterday and today text files into respective arrays, and then compare them and produce three output arrays. One to report on the data that's been added, one to report on the data that's been amended, and one to report on the data that has been removed. So if we compile our application now and have a look at our folder structure. So here is our folder structure. We're going to be loading the today file.txt and the yesterday file.txt. So if we run the application now, our application runs. It's informing us that both the yesterday and today's files have been loaded, and three output arrays have been saved to disk. So let's have a look at the output files. If we bring up the original files, we can see that the yesterday file had a header line and 4 data lines. The today file had a header line and 5 data lines. So if we look at the added data, we'll see the added data is reporting 2 additions, Fred Taggart and Millie McPherson. And these 2 records are indeed in the today file, but they're not in the yesterday file. So the comparison has successfully identified the 2 records which have been added to the today file and were not in the yesterday file. If we have a look at the amended report, we'll see it has a single entry, one for Thomas Robertson, account number 100,003. If we have a look at the original data, we'll see in the original data the person's name was Tom Robertson, and in the today file it's changed to Thomas. So it has successfully identified an amended record. And finally, if we have a look at the removed data.txt file, this will report on any removals. And it has one record, Jill Jones, account number 100,002. And as we will see from our original files, Jill Jones did exist in the original yesterday file, but does not exist in the today file. So what we've successfully done is compare 2 text files, loading them into arrays, and reporting on the differences. While we're performing these comparisons on arrays which have been loaded from text files, the arrays of course can come from anywhere. They can come from a SQL database, they can come from somewhere else in your application and be built up incrementally. So this gives you an easy mechanism by which you can compare 2 arrays and report on the changes between the 2. Now that's handling a one-dimensional file, which is a single dimension array. What we're going to do next is we're going to load the CSV files. We have a yesterday file.csv and we have a today file.csv. So here are our 2 CSV files, a yesterday file and a today file. These are exactly the same content of file as we saw before, the only difference being they're comma delimited and each element is wrapped in double quotes. So we're going to create a new function to perform this comparison. And this new function is going to be almost identical to our previous one. And we'll call this function load a 2D file. It takes exactly the same parameters, the only difference being is we're loading the CSV version of the yesterday file and the CSV version of the today file. So if we just clone this function we created before, and we'll just change the name from 1D to 2D. And the only change we're going to make in here is to change the read the file into an array and substitute the read this CSV file into an array. The parameters are going to be exactly the same. And we'll change the second function exactly the same way. The unique field name we're comparing is still the account field. The delimiter we can take out, as this internally is going to use the parse command with a zerolen string as the delimiter, which will default to the special handling within the parse command for CSV files. Once our comparison has completed, we can use the array dump function. The array dump function is designed to dump a single dimension array to disk. So we have a new function called ArraySave2D we can actually use for that. Its parameters are slightly different and the file we're saving to is a CSV file. And we will do exactly the same for the other two arrays. However, the function we're calling to do the comparison of the arrays is still the same function. The arrayCompare function will actually work out whether the arrays passed to it are one-dimensional or two-dimensional and handle them appropriately. If you pass an array in that is a 3 or 4-dimensional array or anything higher, it will record that in the strError variable and return the value false. So we do a quick compile on that and go back to our folder again. So we will double click on our array library.exe and it should produce 3 additional CSV output files. And there we are, it's loaded both the yesterday and today file and it's saved the 3 arrays. And we now have an added CSV, an amended CSV and a remove CSV. If we look at the added, we'll see it has our 2 records. And these 2 records are exactly the same ones as we found using the one-dimensional array. And if we look at the amended version, we'll see it has found the same amended record, Thomas Robertson. And if we look at the remove report, we'll see that both the one-dimensional and two-dimensional ones are returning the same information. The content of the CSV file is in exactly the same format you would expect to see. Everything is comma delimited and all the fields are wrapped in double quotes. So in summary, what we've achieved today is we've compared both one and two-dimensional arrays, reporting on what has been added, what has been removed, and what has been amended between the 2 arrays. So how did we actually do that in the code? Let's have a look at the array functions library. As you will see from the list of functions at the beginning of the library, we have added a few functions to this library. If we have a look at ArrayCompare, we can see the incoming parameters, the yesterday and today's arrays, and the 3 arrays to handle reporting, our delimiter, our unique file name, and the error. This function calls a number of underlying functions. Its first task is to report additions. It does this by passing the yesterday and data arrays plus the reporting array to report on what's been added, with the delimiter, the unique field name, and the error. In order to report removals, we can use exactly the same function. We merely have to reverse the order the arrays come in, so that the today array is first and the yesterday array is second, because a removal between yesterday and today is exactly the same as an addition when you reverse the arrays. And the final function is to report what's changed within an array. If we look at one of these underlying functions, we'll see how it's actually doing it. We're using the array attribute command to work out how many dimensions both the yesterday and the today arrays actually have. This allows us to ensure that the arrays being passed in are either 1 or 2-dimensional and not any larger. We're also using the inbuilt function name command to return the name of the function the error occurred in. Once we've ensured the correct number of dimensions have been supplied, we can then prep our report data. When you're incrementally adding to an array, one of the performance problems you can come across is if you dimension your array to be a single row, and then every time you want to add something to that array, you add another row and redimension the array, this can be quite time consuming. So one method around it is to redimension the array in blocks. So that's exactly what we're doing here. We're using a constant called array block addition. If we look at the beginning of the library, we'll see that the value of the array block addition is 1000. So the first time we attempt to redimension one of the reporting arrays, we're dimensioning it as having 1000 records in it. This allows you to write up to 1000 records to the array. Once this 1000 record limit is reached in an array, we redimension it again and add another 1000 records. This way you're only redimensioning our reporting array every 1000 records, which speeds up the process considerably. Once you have completed writing to one of the reporting arrays, there may well be empty records at the end of that array. If, for example, you have an array which contains 1000 records and you have only written 200 records to that array, you'll need to truncate it. For one-dimensional arrays, this is remarkably straightforward. You merely have to use the read and preserve command, followed by the name of the array, and in brackets the number of rows you wish to keep in the array. This will truncate the array for you. For two-dimensional arrays, it's a little more complicated. So I've created the ArrayTrim2D function. This function will perform the truncation for you by first copying the data that's in your reporting array to another array, effectively cloning it using the cloneArray function, and then redimensioning your report array to be the correct size, and then writing the data from the cloned array back to the reporting array, effectively doing the truncation. Once you have determined that something has changed between the first and second arrays, we can then use the AddToArray function to add a new record to whichever of the reporting arrays we're currently doing. So these new functions should make your array comparisons much more straightforward. In our next video, we'll be looking at doing indexing on arrays. But that's it for today. Thank you for watching.